When we picture Earth, we often imagine a flawless blue sphere floating serenely in the vastness of space. It's a classic image, smooth, round, and perfectly shaped, like a marble or a ball you'd find in a toy store. This idea is so common that it's easy to forget it's just a simplification. But if you take a closer look, you'll discover that our planet isn't a perfect ball at all. In fact, Earth's true shape is a bit more complicated and fascinating than most people realize. Earth is actually what scientists call an oblate spheroid. That means it's slightly flattened at the poles and bulges out at the equator. The difference isn't huge, but it's enough that if you measured carefully, you'd notice the planet is a little wider around the middle than from top to bottom. Imagine pressing down gently on a soft rubber ball. The sides bulge out while the top and bottom flatten. That's a good way to picture Earth's real shape. It's not something you'd notice just by looking at a globe, but it's there, hidden in the measurements. And Earth isn't alone in this. Other planets, like Jupiter and Saturn, are even more noticeably squashed at the poles. That's because they spin much faster than Earth, causing their equators to bulge out even more dramatically. The reason for this shape comes down to two main forces: gravity and rotation. Gravity pulls everything toward the center, trying to make the planet as round as possible. But as Earth spins, centrifugal force pushes outward at the equator, causing that subtle bulge. So, while calling Earth a sphere works for most conversations, science reveals that our planet is a bit wider at the waist than it is tall. If you measured all the way around the equator and compared it to the distance from pole to pole, you'd find a small but real difference. This subtle difference in shape isn't just a fun fact. It actually tells us a lot about how Earth formed and the powerful forces that have shaped it over billions of years. From the way our planet spins to the way it grew from dust and gas, Earth's not-so-perfect shape is a clue to its incredible history. Why are planets round? The answer is gravity, the universe's master sculptor. Gravity pulls everything toward the center of mass, and for large objects like planets, this force is immense. Over time, gravity crushes and molds material into the most efficient, stable shape, a sphere. Any mountain-sized bump gets pulled down, and the planet settles into roundness. Smaller objects, like asteroids, don't have enough gravity to become spheres. They stay lumpy. But once an object is a few hundred kilometers wide, gravity wins, and roundness prevails. So, gravity not only keeps us grounded, it shapes worlds, stars, and the very structure of the cosmos. That's why nearly everything big in space is round. Earth's incredible story began over 4.5 billion years ago, deep within a swirling, vast cloud of gas and dust known as the solar nebula. This immense cloud, left over from earlier generations of stars, drifted silently through the darkness of space, waiting for the right moment to ignite the birth of something new. Within this nebula, tiny particles of dust and ice began to collide and stick together, forming larger and larger clumps. Over millions of years, these clumps grew into planetesimals, small, rocky building blocks that would one day become planets. As these planetesimals collided and merged, gravity became the dominant force, pulling in more material and causing the young proto-Earth to grow. The energy from these impacts, combined with radioactive decay, heated the growing planet until it became a seething, molten ball of rock and metal. In this liquid state, a dramatic transformation took place. Heavy elements like iron and nickel sank toward the center, forming Earth's dense core, while lighter materials floated upward, creating the mantle and the earliest crust. This process, called planetary differentiation, set the stage for everything that would follow. Gravity continued its relentless work, shaping the molten mass into a perfect sphere, the most stable and efficient form for a planet. This roundness was not just a coincidence, but a direct result of the fundamental laws of physics at play. As millions of years passed, Earth's surface began to cool. A thin, rocky crust solidified on the outside, but the planet's round shape remained, locked in by gravity and the cooling process. The scars of its violent beginnings were slowly covered, but never erased. The roundness of our planet is more than just a shape. It's a fossil record, a silent witness to the intense heat, constant collisions, and dramatic changes that marked Earth's earliest days. Volcanic eruptions and meteor impacts left their mark, shaping the surface we know today. Through all this chaos, gravity organized the disorder, creating a layered, spherical world. The core, mantle, and crust each play a vital role in Earth's ongoing evolution, from the movement of continents to the generation of our magnetic field. The beautiful round planet we see today is a direct result of these ancient cosmic processes, a testament to the power of gravity, the violence of creation, and the remarkable journey that shaped our home. Imagine, just for a moment, if Earth were not a sphere, but a giant flat disk floating in space. What would that world look like? How would life be different? Let's take a journey into this thought experiment and see what strange consequences might unfold. On a flat Earth, gravity wouldn't pull you straight down as it does now. Instead, it would pull everything toward the center of the disk. The farther you walked from the center, the more you'd feel yourself being tugged sideways, as if you were always climbing a hill that got steeper and steeper. Life near the edge would be nearly impossible. Imagine trying to live on a surface that feels like the side of a mountain, with the ground sloping sharply beneath your feet, and the pull of gravity making every step a struggle. Trees would grow at odd, unnatural angles, always leaning toward the center. Rivers wouldn't flow out to the sea, but would curve and twist, all draining inward, creating a strange, ever-winding network of water. Standing upright would be a challenge, especially as you moved away from the center. People would constantly lose their balance, sliding or stumbling down the ever-increasing slope, making daily life a constant battle against gravity. But even if you could somehow adapt, the disk itself wouldn't last. Under its own gravity, it would begin to collapse, slowly warping and curving until it formed a sphere, just like every other large object in the universe. The only way to keep it flat would be with some mysterious, unknown force, something far beyond anything we've ever observed in nature or physics. And even then, a flat Earth couldn't hold onto its atmosphere. With gravity pulling sideways, air would be thin and unstable, constantly drifting away from the surface. The atmosphere would simply slip off the edges, leaving the world exposed to the vacuum of space, with winds and clouds vanishing into nothingness. And if you looked up at the night sky, you'd see that every other planet and moon is round. Why would Earth be the only exception in the entire universe? The laws of physics, as we know them, simply don't allow for a flat, planet-sized disk. Our round Earth isn't just a coincidence, it's a result of the fundamental forces that shape the cosmos. Gravity makes planets round, but Earth's spin fine-tunes its shape. As Earth spins, centrifugal force pushes outward, strongest at the equator. This force causes the planet to bulge at the middle and flatten at the poles. When Earth was molten, this effect was even more pronounced. Today, the equator is about 43 kilometers wider than the pole-to-pole diameter. Stand at the equator, and you're farther from Earth's center than at the poles. This bulge is a permanent reminder of our planet's rotation. Physics in action, shaping the world beneath our feet. The sky offers powerful proof of Earth's roundness. Space missions have sent back countless photos, all showing a curved, spherical planet. During a lunar eclipse, Earth's shadow on the moon is always round. Only a sphere can cast a round shadow from any angle. Time zones exist because Earth is a spinning globe. Different parts face the sun at different times. If Earth were flat, everyone would experience day and night simultaneously. GPS satellites orbit a sphere, using spherical geometry to pinpoint your location. The system wouldn't work on a flat Earth. From ancient eclipses to modern technology, the evidence is overwhelming. The sky confirms, our world is round. You don't need to go to space to see Earth's curve, just watch a ship sail away. Ships disappear hull first over the horizon, not all at once, proving the surface is curved. The same happens in reverse. The mast appears first as a ship approaches. Try the stick shadow experiment. Two sticks in different cities cast different shadow lengths at the same time, thanks to Earth's curve. Climb a hill or lighthouse, and you'll see farther. The higher you go, the more of the curve you see. On a flat plane, height wouldn't change your view. Everyday experiences, from ships to shadows, reveal our planet's true shape. The evidence is right here on Earth. If the evidence is so clear, why do flat Earth myths persist? Some people distrust authority or find comfort in alternative explanations, especially in online echo chambers. The scientific method is our best tool for understanding reality. Observe, question, hypothesize, and test. The round Earth model makes predictions. Ships disappear bottom first, shadows differ, lunar eclipses show curved shadows, and all are confirmed. The flat Earth model fails these tests and can't explain time zones, seasons, or GPS. Science is self-correcting, always refining ideas with new evidence. Understanding Earth's shape isn't just about facts. It's about the process of discovery. That's the real wonder of science.